Hello everyone. Today we're gonna look at the Solow model. Here's the setup. So you have output as this is the production function. Okay, so the output is a function of capital and effective labor, right? So A times N is the effective labor. So assume that A is like a technology, right? And it grows at a growth rate of G, and N is the population, and it grows at a growth rate of N. Okay. Now we're going to assume constant returns to scale here. Yeah. So if I'm gonna let little y t will be equal to the big Y all over the big A n. Yeah. So we're gonna be looking at this as per effective labor terms. Yeah. This is the output, capital, and consumption per effective labor. So because we're assuming constant returns to scale, if I um, divide everything by an, then this will happen here, right? So a t divided by a t is gonna be 1. Okay, and so we're gonna define this function as little f as a function of little kt. So we have here the little yt. Okay, the output per effective worker is a function of capital per effective worker. Okay, and so we can have this diagram here. Yeah. So this is the production function, okay, and this is the savings, okay, times yt. The saving rate is s times yt. So it's like you're saving a constant rate of your income, okay. If you think of y as your income, you're saving syt is like a constant proportion of your income is being saved. And so the gap between the savings and income will be the consumption. And we want to look for the steady state here, okay. So at the steady state, we should have this condition here, just like the law of motion, right? So the capital next year will be equal to the capital this year times 1 minus delta plus the investment. Okay, so the investment is like what you add on. Okay, so that's the saving rate. Okay, so the IT is gonna be like SYT. Yeah. So these are all in big letters, right? So the level capital, level investment, level saving, and we want it to be expressed in small letters. Okay, so small letters being the per capita units. Okay, so this is it. It's this you just apply some little trick here. Okay, and then it becomes this. Okay, so you'll have this little kt plus 1 is equal to 1 plus g times 1 plus n minus kt. These are now little letters, right? So these are per capita terms, okay? And 1 plus g times 1 plus n is just going to be 1 plus g plus n because g times n is assumed to be like 0, yeah? It's very small. So in steady state, because it is steady state, the kt will be equal to kt plus 1, okay? Because that's what steady state means. So we just assume that it's equal to k, right? Steady state meaning it doesn't grow. So your little k today will be equal to the little k tomorrow. So and everything's in steady state, so we will be solving for there should be no t here, okay? So we will be solving for k here, okay? And so we can have here the capital per output in steady state should be given by this. Okay, so the saving rate divided by g plus n minus delta. So the capital per output will be equal to this thing. So as you can see here, if delta rises, what happens? So if delta rises, what happens to this line here? This line goes to the rotates upward, right? And your capital state will be smaller, yeah. If n rises, the same thing, so because this one is delta plus n plus g, if any of this increases, then this line here will rotate upwards, so this capital steady state will be smaller, okay. Now on the other hand, if s is the one that increases, okay, s is this line here, right? So if s increases like that, okay, if s increases, then the steady state capital will go to the right. Okay. Oops. Okay, so the steady state capital will go to the right if s increases. And this is like, the shock, the time shock. Right? So if you have an increase if the shock happens at time t, and you're looking at the output, right? So, and the shock is like an increase in s, then the output in steady state will continue, will increase eventually, right? So we know that, when you have an increase in s, right? The output here, okay, in steady state will be higher, right? So you will go, this point will move to the right, so this point here will move higher as well, so the y steady state will increase, and it's just a plot of how the output in steady state will increase. Now, golden rule is essentially the point where consumption is maximized. Okay, so consumption is maximized. Why do we care about that? Okay, so because your utility function here, okay, is going to be a function of consumption, right? So you want the golden rule steady state because that's when your consumption is maximum. Okay, remember, consumption is the gap between y and s. Yeah. So if you have very little k, the gap between y and s is small, right? Now, there's a sweet spot somewhere here where the gap is maximum, the consumption is maximum. And that's the idea behind the golden rule. And so how do we find that? Okay, so you see it when the tangent line is parallel to the depreciation line. So if you make a line parallel to this line, okay, parallel to this in here, in the y, that's where the golden rule saving rate would be. Okay, so we are looking for the golden rule saving rate in here. So that's the idea behind the golden rule. So we are going to construct a tangent line parallel to this line here, the depreciation line. Okay, right. And so after some algebra here, we have this condition here for the golden rule. Yeah. We'll have the golden rule saving rate. Okay. The golden rule saving rate will be given by this, so k over k alpha. Okay, so this one is a numerical example here. So, but you can solve for it without the numerical example. Okay. So the idea would be to have this, and the marginal productivity of capital must be equal to delta plus n plus g. So this is your working equation. If you do that, then you have this condition, and then you can now get the k. Okay, at the golden rule, the k golden rule will be this, right? And then you know that k golden rule is also a steady state. Yeah. So now that you have the k golden rule, then you can, this is the golden rule. So you can have k over k alpha, so you have this. And you can now get the, remember k to the alpha is like your y, yeah? Okay. So, sy is just your the saving, right? So from here you can get the saving rate golden rule, okay? That's the end of it.